Good afternoon. We'll get started in a couple of minutes. Just a few logistics.
Okay, welcome to NVO3. We'll just give it another minute or two since it's first thing after lunch. I'll leave the note well up there. Oh, we're just waiting. But I don't know if Martin's going to come along. Martin's out. Oh, good. Okay. Okay. So this is the note well, which you've probably seen many times this week. But if you haven't, please note it well. Okay. So blue sheets. There's two blue sheets. One going down each side of the room. Please sign the blue sheet. Whoever's you taking the notes. Thank you. This is the agenda. We had a few last-minute tweaks to the agenda. So we've got the working group status update first. Then we're actually going to have the security requirements update from Daniel. Is Daniel in the room? There he is. Okay. I seem to have a blind spot on the side of the room. And then we've got Elango presenting an update on the working group last call progress for Draft Geneve. He's going to be remotely presenting. We then have an update on some IOAM drafts relevant to NVO3 that are being done in the IPPM working group, first of all, but we also need to have a discussion on where those really sit, if it's IPPM or NVO3. Things I'm going to go through a new draft on overlay subnet architecture, and then Sammy's got this is a new addition to the agenda. It's going to give us an update on the Geneva applicability for SFC. Any comments on the agenda? Thank you very much. Okay, milestones. So we said we would update these after the last IETF, and we've now finally done so. But of course, because we left it so long, they're out of date again. I think So we've removed a couple of the existing milestones around control plane solution and control plane requirements because not a lot of progress was being made on those, and added a couple of milestones on security requirements and solutions, since that's a significant focus of the work in the group at the moment. We will discuss updated deadlines for those, or dates. I think it's best with the draft authors to see how long they expect it to take to progress through the working group. Right, document status. We have quite a few RFCs now, but no new RFCs since the last IETF. For the major working group documents, so the data plane encapsulation, draft Genève, we started a working group last call for that, and it's in progress, and we've had some reviews on that, and there's been some discussion on the list. That's on the agenda today. The design team draft, which is draft IETF NVO3 NCAP, that's currently expired. We'll talk to the authors about that, but we'd like to see that revised or revived after draft Genève has gone to the ISG, because as we discussed in the past, the idea was to publish the DT design team output after Genève had gone through. We have an ongoing working group adoption poll for the security requirements draft, and there's been some discussions on the list of that as well. We think that may need a follow-up virtual interim meeting depending on the progress that we make today. But it is on the agenda. We had a working group last call for the virtual machine mobility protocol document, and we requested ops area, routing directorate, and TSV area reviews. We had quite a few comments back from the ops area and TSV reviews. The authors have been in discussion with those reviewers, but we don't really have an updated draft yet, and some of the comments seem to require updates to the draft and then some shuttling back to the reviewers to try and get consensus there. Are there any of the authors of the VMM mobility protocol in the room? If they could give us an update on what they plan to do. Okay, we'll follow up with the authors anyway to try and make some progress there. And since the last IETF, we have we've adopted a new working group draft, which is the EVPN applicability draft for Genève. So this is basically an applicability statement, and there's a corresponding draft in the BESS working group, which are the protocol extensions required for using Genève and EVPN. Okay, any comments on the working group status? Oh, okay, thanks. I think next up is Daniel. Oops. Hold on. No. Okay.
Hi. Okay. So the security requirements. So where we are. So we had a few discussions on the mailing list.
Could you speak
on the mic? Okay. So we had a few discussions on the mailing list, and my intention here is not to go through all the requirements. It's probably something that needs to be discussed during an interim meeting. But what I'd like to understand is if we have a good way of working, and if we have a common understanding of how to read the requirements and what the requirements are expected to fulfill.
No, just done it now.
Okay. So in the initial version of the draft, we had one set of requirements, which were what a Geneva security mechanism should fulfill so that we can secure any Geneva requirements, any Geneva deployments. And then the feedback I received was that, well, a lot of people were interested to have a kind of checklist to check against the Geneva requirement and see whether the deployment can be qualified of secure or not, or to be able to evaluate the security of the deployment. So this is why we came with two kind of sets of requirements. So the document is structured with a description of the threats, so just to understand what we have to care about, and then two kind of set of requirements, which could be seen as checklists, and this is a different type of checklist. The first one is really operational, so it's really a list of requirements that one should check against. So it's really to evaluate how your deployment, the Geneva deployment, is secure or not. So in a lot of them, you have some kind of conditions because it depends also on the risk you're ready to accept or not. So this is this kind of list you have to check. The other one is really related to if we want to design or have Geneva security mechanisms, what requirements this mechanism needs to fulfill. And this Geneva security mechanisms is really not defined now. It really has to be defined in another reflection. So we're just about to list the properties this mechanism is to fulfill. And of course, so you have two sets of requirements. So the purpose of the next slide. If you want to check how secure is your deployment, you have to match any of the requirements, and you have to pass through all these requirements. But a lot of them have some conditions. So maybe in most of the cases, some of the requirements don't apply, in which case we consider that you pass the requirement. So it's not that you have to set a lot of properties that you're not taking advantage of for your deployment. As a typical example, if you want to secure with TLS, in some case, you might fill all the requirements because that's sufficient for your specific deployment. On the other hand, if you want to use, I'm just taking as an example, TLS as a generic Geneva specific mechanisms, then you have to match all the requirements. And in some cases, it seems hard that TLS fits all these requirements, but that's something we have to evaluate later. So that's basically how the set of requirements is built. So now I don't know how much time I have. We may start to go through some of the requirements to evaluate, or I can take the feedbacks, or I don't know. Is there anything, do you think the two sets of requirements are valid, or if there is one we should remove, or if you want the requirements to address another type of question, or what is the feeling of the room, the working group?
So, sorry.
No, how many of you care about security?
So just one observation I'd make. You've got both operational or operator requirements so that they can judge whether or not a deployment is secure, and requirements on a protocol to meet a certain security criteria in the same document, which seems to be possibly confusing two issues.
I'm fine with that. Yeah, I can remove some of those, but well, the operational ones have been added because that was something that I feel that was requested. So I'm fine removing those. It's only removing text.
I don't know if it's removing. It's just should you have an operational security requirements draft separate from requirements on the protocol design to make it secure?
Yeah. So we can split those requirements in two different drafts. I'm fine with that. We can have one draft with a threat description, another was the operational requirements, and another one for the GNF security mechanism requirements. I'm fine doing this way, but I have the impression that I'm not sure. I mean, it's 3 documents instead of 1, so I don't know what's going to be the overhead and the commitment to.
Elango.
Yes. Are you able to hear me?
Yeah, go ahead.
Yes. So I mean, submitted a bunch of comments on this draft, and also I submitted a comment earlier today as well. There is a fundamental disconnect on how to frame the the requirements for the protocol as well as for the operational evaluation of the operational requirements as well. And so that's basically where the whole lot of the comments inside makes an assumption that you need to meet all of these requirements in order to in order to claim that this is a secure Geneve deployment. But whereas that is not necessarily true, because the operator will evaluate the risk associated with their specific deployment and see maybe 1 or 2 or few of the requirements that they need to satisfy, and it meets the objective that the deployment is secure. Whereas this document takes an approach that pretty much all the requirements have to be met in order to claim that it is a secure deployment. I haven't seen any precedents for such an extreme view or an extreme approach for other transport encapsulation protocols. So why that we have to go into this level of details, and in fact it gets into implementation details as well in some of the areas, which is burdensome for the operator, and it's also burdensome for the implementer, and which is not necessarily needed for securing Geneve. I mean, take any protocol. I mean, replace Geneve with any other protocol like Lisp, or you take a protocol like MPLS over UDP, or IPO or IP. None of those protocols have to go through all of these such kind of requirements, but they're still people are able to securely deploy those protocols and successfully operate it as well. And as that's the fundamental disconnect here, and so I think we need to address that one first. Otherwise, we have been going in circles for the last 2 or 3 iterations. We can always, once we resolve that, we can always go back and fix some of the individual requirements. And that's basically my comment. If you want, you can go through some of those examples and then show it to the rest of the working group. I'm not sure how many of the working group members have already gone through this draft in detail. But I think it will be good if we can get more input from people who are, in the operational experience, or the people who have, protocol implementation experience, and that will be really good. So that's basically my comment.
Yeah.
This is Sam speaking as individual. One thing, Ilanga, I'd like to want to know is it with respect to the classification that a specific protocol, or in this case, the security requirements for Geneve, indicates whether it is secure or not? Or are you worried about the amount of requirements out there, or one too many, that irrespective of one or the other are met, the protocol is still secure.
Is that a question to
I mean, the concern is for both cases. So if you look at individual requirements, I think some of the examples, if you go through subsequent slides, you will see that where the document talks about multiple different requirements, and then it also claims that you need to have a Geneve specific or security mechanism, and then all of these requirements need to be met in order to claim that Geneve can be deployed or it can be used in any Geneve deployments, and that's the approach that the document takes. But I don't think that is necessary.
Okay, so if you remove the criteria that the Geneve could be secure, and these are the requirements which could be met, and we need not classify that by meeting them or not meeting them will make it secure. Does that address your specific concern?
Just one possibility. I think there is an echo on the link. Yeah. So I think there is again echo on the link.
Yeah, we don't have any echo on this side, so we can speak.
Oh, you don't hear it? Okay, I think I'm getting it here. Right. All right. So what I I'm sorry. So the challenge I'm having is that I think we need to first address how do we frame the problem, and that's basically the whole challenge. I mean, what is the document's objective? Is it to go and give guidance to the deployers that these are the possible or potential risks in an environment, and if you have to address risk number A, then you need to be you need to fulfill these 2 or 3 requirements in order for you to deploy in a secure manner. I mean, that's how it needs to be approached. But that way, it gives guidance to the operators so that they can evaluate the risk and accordingly pick the right requirements that meets their needs. And then you can go to explain another risk like that, and then go with that approach, rather than saying that you need to if you prescribe like 10 requirements and say that all these 10 requirements are to be met in order to call that this is a Geneve secure deployment, and that is unnecessary, and people might start to ignore it because people who we really wanted to give guidance to the operators and not to over prescribe something that operators may not really use it or care.
So the way I try to write the requirements, especially the operations one related, are we have classification for each of the threats we mentioned, and I try to in the text to be very cautious to provide a condition when the requirements applies, which means that if the condition is not met, you consider the requirement is applied, is a match. So, for example, I'm taking the first one. I'm saying that by default you should encrypt the inner payload, but I'm also saying that you may disable this capacity if you believe so, or if you don't believe the risk is too high. So in that case, my intention was to say, if you don't know, you encrypt. But if you carefully evaluate that the risk is sufficiently low, then you can disable these mechanisms. So as long as you check those, I would say security operational requirements 1 is met.
Okay, go ahead, Greg.
Yes, Greg Mirsky, ZT. I just wonder, how can we get their input from operators themselves and not speak on their behalf? So maybe some blind poll and ask them to evaluate because otherwise we'll be just, my opinion, your opinion. We need some objective information, not that what we think that operators will do or not do. And then we can just make it practical, realistic, something that helps operators and set certain requirements. Yes, there will be requirements. There will be certain things that you need to do, you like it or not, if you want to claim that this deployment is secure. But I think that we need to seek information from operators directly.
Sam speaking as individual. I think if I understand, even Elango's comment is in line with what you say is we provide the necessary guidance and let the operator choose. And to elaborate on your question, it is not just NVO3's problem, it is pretty much IETF's problem where operators have to really provide feedback, and it is very hard to get, first of all, and second of all, like how actively we can actually pursue operators to provide the feedback. So this is a
But we have some operators here. Maybe they want to volunteer and suggest how they can give us information in a blind poll.
Sure. Feedback is always welcome, but we can't force someone to speak on it.
So, but the feedbacks are, of course, more than welcome. But the thing is that the requirements came from an analysis from the threats related to the Geneva protocol and its deployment. So we are not going into operational deployments that are not related to Geneva. So I guess at that point, the security analysis might be sufficient to provide, a complete set of requirements. But then from this requirement, I don't understand how we could if we have a list and you say, well, you pick the requirements you want, it means that if you are able to meet one of those requirements, you will be able to claim that your deployment is secure. It's a little bit hard to buy or to sell. So this is why I don't understand how we can have a subset of the requirements and people choosing just the one they want.
Well,
Frank Bruckner, so I have a more fundamental question. How are you expecting that somebody reads this document, given that it's informational? Is it just like you want to use this document to self-assess yourself, to understand whether your Geneva deployment is considered quote-unquote secure and what security means? Or do you expect that an implementer would follow this? So I'm a little puzzled on what the document wants to go and achieve. Do you want a binding statement that, well, the vendor that comes up with a Geneva stack does certain things, or is it just like for self-assessment and certification and what have you?
So I think this is part of my point earlier on about mixing up the operational security requirements with requirements of security requirements on the protocol or
I
the
get that.
implementation. Yeah.
And it might be useful to go and clarify that. Right?
Yeah.
Okay, so to answer it briefly, the operational requirements are, if you have a deployment, Geneva, and you want to check how secure you are, or if you're secure or not, it provides you guidance and aspect to look at. However you deploy it. For what I call the security Geneva mechanisms requirements, those are intended for architect or protocol designer, and to elaborate what we could call a Geneva security mechanisms, which means it's a mechanisms that can secure any Geneva deployment. So the next the category, the latest set of requirements will be used to define how can we define like Geneva security options or a way to secure any Geneve deployments, which means that if you implement this one, you don't have to look at alternate solutions, or, well, you may use those, but
I think we kind of need to move on to the next presentation. Can I have a show of hands for who's read this draft, the latest version of the draft? Well, it doesn't have to be the absolute latest version. If you've read any version of it, but, oh, we've got one comment on there. Go ahead. We have no audio. We have some audio, but not.
Sridhar, could you speak up?
Yeah, sorry, I'm having a problem with my feed. Can you hear me okay?
Yes.
Yeah, so I have similar comments as Ilango said that, again, it starts from the basic as to how to actually frame the requirements, and also in terms of the all or nothing approach. So we do want more people to actually read the draft and comment on the list, whether this is the direction that we want to go on. Thanks.
Okay. So so definitely like some more feedback on the list and continue this discussion on the list. We've been talking about having maybe a virtual interim meeting just on security to try and resolve some of these issues around the draft. But if you could read the draft, if you have concerns or comments on it, post them to the list. But we will send a notice for a virtual interim meeting, I think, some point in the next month or two. Thank you.
Okay, thank you.
So next is Ilango. Go ahead.
Yes. Are you able to hear me?
Yes.
Good. So I'm going to give an update on the progress of the working group last call. So I'd also like to thank Sridhar, who had been working with me hand in hand in order to do the responses as well as analyzing the comments on the list. So please go on to the next slide. So draft Geneve was updated on October 7th for the working group last call. And in this version, we addressed the comments that we received mainly on the security considerations section. And based on this, the chair called for the working group last call on October 9 to 26. We received comments during the last call and responded to those comments with the proposed text. And this was all in the mailing list. And the chair also requested for an early review by the security directorate. And we also got feedback from that review, the early review, and the feedback was positive. And to give a quote, like, the document is written in a clear manner with the thorough security consideration section. But in addition to that, there were few comments, actually, to be precise, there were 3 comments on from that review. And then we also proposed text to address those comments as well. And then there was also a request for an early review by the transport directorate. And then we did not get any response or comments from that early review. But that might be still open. Then moving on to the next slide. This is regarding. This goes through the working group last call comments that we received on the reflector, and we're not going to go through each and every comments. Pretty much all of those were discussed on the mailing list, so you can go and see the details. But what I'm presenting here is the theme, the theme of comments that we received, and pretty much we're covering all the categories of the comments that we received. So number 1 is the guidance on the TTL handling. There was a request for guidance on the TTL handling. And what we said is RFC 2003, which is the IP and IP protocol, and that provides guidance on the handling of TTL. And this model is applicable to Geneve, and that is being recommended for use with Geneve. And we also put out a proposed text to the satisfaction of the commenter, that was Anup Ganwani. And then we also provided reference to RFC 8293. This is the new RFC that came out of this working group that gives the multicast framework. And this is an informative reference. And we also updated reference in the IANA section to RFC 8126. And then there was also a suggestion on option class assignment. And we did clarify that we have a range for reserved for IETF review, and we also have a range with the lenient policy that's based on first come first served policy. And then there was also a request on the clarification of the OBIT usage, and we also proposed text to clarify this bit is used to indicate control message between NVEs. And also we proposed to remove reference to OAM and rename that bit as a control bit instead of an OAM bit. And that's regarding the theme on this slide. And I can go to the next slide. Yeah, here we further have clarification on options processing and checking. There were few comments from multiple different commenters on option processing and how it needs to be handled. And so we added, or we proposed clarifying text in order to address those comments as well. And there was also a comment on the interpretation of option by the transit devices. Whether how is it being, what will be the responsibility of transit devices what's the responsibility of the endpoints. So we proposed text to clarify the responsibility of endpoints and transit devices in both cases of option generation and termination versus and also we proposed text for the security consideration section as well to clarify this. And there were a bunch of comments, and this came in from Daniel himself. And so we did propose text to clarifying those statements as well, and also to remove any redundant text for better readability. And we also had some comment on the reserved bit. This came in from the early SecDAR review. And so we did propose comments. This is more of a minor clarification in order to fix that. And they also had a comment on the options, which kind of very similar to the Daniel's comments or Anup's comments, and we addressed that one, or a proposed text to address that one as well. And there are a few other editorial comments that was from Anup Ganwani as well as from Daniel Migal that we will address that as well. And moving on to the next slide. So we will be ready to publish an updated draft addressing the working group last call comments in a week or two. And so the draft should be ready from there on to move on to the ISGF review as well after addressing those comments. So that's basically the summary of in the progress from the working group last call. So any questions or comments?
Greg.
Yes, Greg Mursky, CT. I appreciate that your consideration of my comment on OBIT. Couple notes to what you explained in details. I like that you decided to remove reference to OEM. A little bit, I think, confusing that it's now indicates the control between NVEs. Is it implying that there is a in-band control protocol between NVEs in Geneve? That's something, just hold on a moment. And again, if I remember correctly, Geneve header already have a CBIT. So how this new interpretation of OBIT compares to the existing definition of CBIT? I thought that CBIT is a command bit. This is a control bit. What's the difference?
No, I think these are two different bits. We did not change the description of the OBIT. Pretty much the description of the OBIT remains the same. It was meant for exchanging control messages. And then that way, the idea is that when this bit is set, it indicates that control message is being exchanged. And those control messages can be forwarded to an exception queue so that you can process it in a slow path or an exception path. And that was the intent of this bit. And examples of control messages could be link. There could be a virtual link heartbeat kind of a message, or it could be BFD kind of a message that could be flagged as a control message. And these control messages are different than the data message, and that needs to be handled in the control path. And that's the intent of this bit. And then whereas the bit that you talked about, the C bit, is actually critical options bit that indicates that the Jenny actually carries now critical options. That's basically the intent of that one. So that way, and there is also a special, there's also a description on what it means by critical options and how do you handle that. That's been clearly described in the draft as well.
But again, I want to point that not all OEM are processed in a control plane. So generalizing that OEM as a control that is processed in a control plane, I think that is very risky, and will lead a lot of ambiguity. Again, I'll encourage to just remove this bit from this specification and leave it for later discussion.
There is plenty of precedent for having an associated control channel with something like a pseudowire, for example, and it doesn't define whether you process it in the data path or you process it in control plane.
I agree, but since we have a protocol field, I absolutely agree with your comment. Since we have a protocol field, the protocol can define associated channel, and there is no apparent reason to have another mechanism to indicate that this is an associated channel message. Okay, so the associated channel sufficiently identified by the protocol type.
It need not be a separate control protocol, right? So it's basically the next protocol could be the same, right? For example, next protocol could be Ethernet, and your control message could also be an Ethernet. So this flags that it's a control packet, and then it needs to be handled through the exception path or a slower path, and that's how it's being used. And so that's the reason why we have this bit.
Again, I think that we're going in circles because we already have with Jesse this discussion. What's the purpose of using Ethernet encapsulation for NVE to NVE messages? They can have just their control message format identified by next protocol, and then shim layer identifies the type of the message, so you can decode it easily. Again, I don't see any rationale to have this bit used and involved, because if you look at the draft, and I referred to this draft in my discussion on email with Jess, that OEM identify using dual mechanism of flag and next protocol to identify OEM creates ambiguity. So let's.
We said that we will remove the reference to OIM here. We are again bringing back the point about OIM, right? We are talking about the control message, but that may or right.
Again, if we say that we identify associated channel easily identified by the next protocol. Next protocol can say, okay, this is associated channel. You have a shim layer that identifies the time of the message in associated channel, as we do in pseudowire VCCV or MPLS LSP. And again, there is no apparent need for the flag. Why make it several ways, this way and that way? It creates a problem with interoperability, implementation. So
that's not actually the case in the pseudowire case. You think about IP pseudowires, and you're running if you're running VCCV with IP encapsulation in the pseudowire, then you have both the bit indicating that this is a packet on the VCCV channel, and that creates the exception that then gives you that you then look and see it's an IPv4 packet, and that tells you then maybe it's a VCCV ping message.
You actually have type after VCCV exception.
You have type after VCCV exception. So that distinguishes it from a raw IP packet. belonging to the user data on pseudowire. So there are precedents, a number of precedents for having an exception bit and then a protocol ID.
Okay, but I think that in this case, it creates ambiguity because why between two NVEs we use any encapsulation but just message?
You could choose how you want to implement.
But
If you don't want to implement, yes.
but then it causes more of you need to advertise your capability, otherwise there will be a problem with interoperability. If that's exactly the situation I'm concerned with. If people choose different, not compatible ways to implement it, then OEM would not interwork between implementations.
I don't think that makes any difference whether you've got an exception bit or not. You're either capable or not capable of receiving and processing that packet.
All right.
Frank Brockner's real quick, could we maybe first see the updated text and then rediscuss?
Yeah.
Because that might help clarify whether and how that bit would be used in the future.
Yeah. So Lango, I suggest in order for us, you need to probably post the new version of the draft. I'll keep the last call open for a while and I would request people to review the new version of the documents, and we'll give it a week or two for comments.
That's correct. So that's correct. So the proposed text was also in the mailing list, so you can also take a look at it. But then, right, we will publish a draft within a week or two that incorporates all the comments that so far we have addressed here.
Okay, thanks.
Thank you.
Okay, thanks, Alango. Next, I think we have Frank. Sorry, Tom. Which one is this?
Thanks. My name is Tal. I'm from Huawei. And we're going to talk about two drafts which are related to IOM over Genève. One of the drafts is led by Frank Brockner, and the other is led by Brian Weiss. Next, please. So just a few words of background about our IOM in general. So what we want to do is we want to be able to send telemetry-related metadata, which is piggybacked onto data packets. And this information should be carried either between endpoints or on a hub-by-hub basis. This is called hybrid type 1 OAM. And basically the way IOM is defined, it's defined in a generic way, which means it can be transported over various types of encapsulations, IPv6, SRv6, NSH. And the metadata we're talking about can be, for example, timestamps, node IDs, transit delay, and other types of metadata. And the base document is a working group document in IPPM. And what we're going to focus on right now is how IOM is transported over Genève. So this draft, which was submitted to IPPM, describes how IOM can be transported over Genève. And the idea is that we use tunnel options. So here we see the Genève header. And then there's a tunnel option, and the option class specifies that we have an IOM option. Okay, so inside the option, we have the IOM data and metadata, header and metadata. And the idea here is that if you have a node which is not IOM capable, it can just skip over the tunnel option. So this is the current draft. And then there's another draft, relatively new, which describes how IOM can be transported over Ethernet using a dedicated Ether type. Now, assuming we have a dedicated Ether type for IOM, this is still not the case, but if the future will have one, then in Genève, the protocol type can be that Ether type, and then it can say, okay, the next header is actually IOM. So after the Genève header, we're going to have IOM header, then IOM metadata, and then it's going to be followed by the next protocols. So that's another way to go. And so we have two drafts, and they define two different things, but at the end of the day, when we ask the question, how do we see IOM transported over Genève? These are two possible use cases of doing that. So why are we here and why are we presenting this? First of all, these two drafts have both been submitted to IPPM. In general, the base document is a working group document in IPPM, and also some of the other drafts which deal with encapsulations. And the idea was that most of the IOM work is going to be processed in IPPM, unless in some cases some working groups will prefer to adopt some of these documents. So for example, SFC has adopted the IOM over NSH and the POT draft. So these two are in SFC. Most of the rest of these drafts have been presented in IPPM, in some cases also in other working groups. And the reason we're here is, first of all, we'd like to get your feedbacks, and we'd be happy to hear any comments. And Greg, you're the first one.
Okay, thank you. Greg Merskiziti. Couple questions. So first, we had a very interesting discussion on security aspects in Genève. So what are mechanisms for integrity and confidentiality protection in IOM over Genève?
Okay, so first of all, we have POT. POT is being discussed in the SFC working group, but it's not necessarily strictly for NSH, right? POT is kind of a generic mechanism for IOM.
POT doesn't have protection of integrity of data transported in IAM.
It has an optional mechanism of protecting the integrity of the IOM metadata.
Which is?
It's part of the draft. Okay. To have an HMAC, which covers the IOM part, and then you use that, Frank, correct me if I'm wrong, and then you use the Shamir secret sharing for sharing the secret between the nodes along the path.
Okay, so that's integrity, confidentiality.
We haven't analyzed that yet, and actually it's a good question whether we need confidentiality in this case. Do you think we need confidentiality?
Well, I think it's discussed in context of Genève.
Okay, so it's a valid question. Any other feedback about that specific question, we'd be happy to hear.
Okay, another question is, so I understand that now the proposal is to use next protocol code point to identify IAM payload and place it after the Genève header, ahead of payload protocol data. What happens if the node doesn't understand, is not upgraded to support IAM? It will drop the data, right?
Right, so again, we presented two different ways here of using IOM over Genève. The first one, as we said, an IOM node and IOM blind node can skip over. The second one, an IOM blind node can't skip over. Okay, you have that's one of the main differences between these two options.
Well, another difference is that TLV is limited space in Genève. So the amount of information that you can put in TLV is very limited. It's very limited.
128 bytes.
Yes, it's limited, especially if you add a HMAC on top of it, 16 bytes. So what left? And couple nodes. Okay, so basically you will fill it with HMACs and overhead for TLV. My question is, so why not to collect and transport data separately of the data packet. So you can hit with IOM data measurement, but then collect data in a separate follow-up packet. And there is already a proposal for that.
Thanks. Any other comments or questions?
Well, I had Frank Brockner. I had one for mostly from a Genève perspective. If we use Genève, right, and we use our own traffic loss there, we'd be as much protected as any other TLV in the Genève header from an integrity and security protection, right? So we basically leverage what the base protocol gives us. So there's nothing specific. So I think the request then is, it really comes down to, yeah, we want a code point for Genève to go and carry IOM data. I think that's the real base request to the Genève working group. The other option, the kind of carry it side by side or along with, carry the IOM data along with the Genève header, that's almost like in parallel, right? And it is something that people could go and implement, but it is not specific to Genève. It's just Genève happens to use an either type. And well, people can go and sequence the header in as they could do with other protocols, say GRE, whatever. So I think from a discussion-focused perspective, I'd appreciate thoughts on whether people see that as useful. We had the earlier comment that, yeah, there is a restriction because the length field is just 5 bits. So 128 is relatively restrictive. That said, I've not seen deployments with Genève so far, especially in overlays that have a load of hops, right? So 2, 3, 4 hops might be completely feasible. Any other thoughts?
Barak, it's maybe theoretical, but if we are so much considering the length as a limiting factor, is it on the table to extend that?
To extend the size of the tunnel option, that is.
The option length, yeah.
Okay. Any other comments, questions?
So just one question on Michael Smith, sorry. Is there an ether type already, will an ether type already go forward for IOM regardless of what Genève does?
Yeah, so first of all, this is a new draft, so we haven't done that yet. But one of the things that was discussed in IPPM this week was that one of the steps along the procedure here is to allocate an ether type from the IEEE. And apparently this is a well-known process here in the IETF. Yeah.
So that's use cases beyond just Genève.
Right. This is just one of the use cases. Yes.
So likely we would have to, if it becomes an option, we would also have to deal with the case where it's on the, it is in the inner packet anyway.
Right. Assuming this draft is adopted. Yes.
Okay. Thank you.
Yes. Thanks.
Alango?
Yeah, regarding the length of the options, this was already discussed, and there wasn't a consensus to make that change. And also there are, as it was shown, right? So there are already 2 different mechanisms. So if something that can fit, it's not just the OAM message alone, right? You have to carry other options as well, and that's the reason for the whole TLVs, just not to carry one option. And so you also have an alternate mechanism if you wanted to have a length larger than 128 bytes, as it was shown here. So as appropriate based on the usage models, you can always come up with different mechanisms too for OAM purposes.
Barak, can you please explain what the mechanism to extend beyond 128 bytes? Or I didn't get it right.
Ilango, did you get the question?
No, I did not get the question.
Sorry. If I get you right, you said there is a mechanism to extend it beyond 128 bytes. Can you please explain?
I didn't say extend it beyond 128, but basically what I was saying is, one of the methods that was shown here is to use the TLV, and the other mechanism is to use the next protocol type in order to carry it, right? So there are two different mechanisms.
Right.
That was proposed as part of the OAM, right? So IOAM, right? If you look at this presentation.
Yeah, but I think we are kind of forced to trade off capabilities, right? From one end, we will not allow a device that doesn't support IOAM to be able to parse and potentially decapsulate the packet. On the other end, when we implement it using TLVs, we are currently restricted with 128 bytes, which could be sufficient for some use cases. For others, it may not. So if we can, I don't know, combine the benefits and have larger TLV space, maybe it's a good solution.
I think for most use cases, this has been working well, the 128 bytes. And as I said, for IOM, I think there are other ways to solve this problem. And I don't see a reason why, that needs to be by increasing the TLV size.
Which ways?
And if you do, sorry?
Which ways? You said that there are ways to solve that, but I'm not aware of these.
Isn't that was shown right just now in this presentation? There are two different mechanisms that are being shown.
From my perspective, it's a wrong way. Like, it doesn't allow devices that don't support IOM to process Geneva header and the overlay. So I don't see it as a valid solution.
Actually, Greg Mirsky again. I probably use a stronger language that Barak. Introduction of IAM in a heterogeneous system will break the services because packets will get dropped. It's not that only the node that is not supporting IAM in this manner with a dedicated Ethernet type would not process IAM. It will drop the data packet. And that definitely should not happen. So we need to understand that this proposal requires that system be homogeneous. The whole domain has support IAM. Their way of using TLV is less intrusive. Because yes, you don't support it, well, no harm done, you do deliver data. You just don't get the measurement. Well, not good, but no harm done. In second proposal, there is a harm can be done.
So you mean you're supportive of extending the tunnel option to over 128 bytes?
No, I'm not supporting. I'm just illustrating to Ilanga that the second proposal is harmful.
Okay. I think, as Barak said, it's kind of, it's the other alternative. I mean, since we don't want to limit only to up to 128 bytes, we're presenting two options. And I think it's a bit of a broader question, not just in this scope, but in general, whether we think there are other use cases that will require more than 128 bytes. I know this was asked in the past, but maybe it needs revisiting.
Again, I tend to a little bit disagree with what you said, because I think that it's not the way that we should choose between one of them. We should have a good solution. I think none of these currently is excellent. Maybe we can try to make the TLV base better.
I should have stayed here. Again, Greg Mirsky. Yeah, I should have stayed here. Or just to choose the different method. Collect it in a separate packet, follow-up packet, with no restriction to their length and no risk to impact the data flow. Okay, so basically, I'm just pointing out that there is a third alternative. Do not piggyback data on a data packet. Do not piggyback telemetry information on a data packet, period.
Barak, I just can share that at least some feedback we got from operators is that duplication and then sending the data in parallel is not a good option from their perspective.
Okay, I think that we reached the point to have this discussion on the list.
Yeah, good, thank you. So one of the discussions that the chairs are having at the moment with the authors is where this work resides. It'd be interesting to see if you could raise your hands if you'd be interested in reviewing these drafts within NVO3. Okay, that's good. There's a fair number of people interested in this work here. Great, thank you.
Thanks.
Thanks.
Okay, good afternoon, everyone. My name is Ting ZT. This presentation is to propose to enhance the architecture in NVO3 to support subnet.
Go ahead. Isn't it right? Should right.
Okay. So why do we need to support subnet? In the IETF 101 meeting, there is a topic about network slicing. One of the draft mentioned that we need to support subnet interconnection. It mentioned that there are several possible reasons to spread an end-to-end network slice for management, including to cross administrative domain boundaries, to interconnect parts deployed over different infrastructure technologies, and to spread a slice system into smaller sections for sharing, reusing, scaling, or facilitating management. And furthermore, as is described in encapsulation draft in NVO3 working group, several overlay technologies such as VXLAN, GPE, GNIB, GUE, etc., has been analyzed. And as we know that every technology has its customer, but for an end-to-end connection in a virtual network, customers may use different technologies on MVE, especially when the MVE on vSwitch. So here mentioned the subnet. We need to extend the NVO3 architecture to support the subnet. The subnet is a little different with the virtual network. It cannot be activated in isolation. It must be interconnected with other subnets to form a virtual network or to form an end-to-end connection. To support the subnet, we need to support staging operation. The staging operation is to interconnect the subnet to form a virtual network or provide an end-to-end connection. Next. So in NVO3 architecture, we propose to introduce a new component to support the staging operation. The new component generally may be on an NVE, so we call it a staging NVE, SNVE. The staging NVE is worked as a staging gateway for subnets. The main task of the SNVE is to stitch the tunnels to form an end-to-end tunnel. In order to support the stitching operation, SNVE should have such the following functions. It should support several technologies if needed, and SNVE can identify the customer's traffic. It should do mapping for subnets and do translation for between tunnels. SMAE is same with other components in the architecture, is that it should do fault and performance monitoring for underlay and overlay network. Okay. Okay, in this diagram is a reference model of SMAE. In this diagram, we can see that SMAE and MAE1 belongs to subnet 1, and SMAE and SMAE2 belongs to subnet 2. So if we want to establish the connection between MAE1 and MAE2, we need SMAE to do the stitching operation. The SMAE provides the interconnection between subnet 1 and subnet 2, like a gateway. It connects WAP1 in MAE1 and WAP1 in MAE2, so that it can stitch the tunnel 1 and tunnel 2. SMAE is also different with MAE because the SMAE only forwards the traffic in the bridge network, and it's never terminated in a bridge network. Next. Okay, that's it. Any comments and questions are also welcome. And we will refine our draft according to the comments after the meeting. Thank you.
Thanks. Any comments? Okay, thank you.
Thank you.
Okay. Good evening. My name is Sami Boutros. I'm from VMware. I'm going to be presenting today applicability of the Geneva cap for SFC or service function chaining. This draft, in history, we presented it last year, and we had few comments on it. So presented it November last year in at IETF last November, and since then we have made some updates to it to align it, I think, more to the SFC architecture, and to as well make few changes to the mechanisms used and so on. So we'll go over that in the next slide. So next slide, please. So as a background for SFC, service function chaining architecture have a service function chaining group have defined an in-cap, which is the network service header or the NSH in-cap. And that in-cap is used to in-cap packet that has to travel through a service function chain. So inside the NSH in-cap, it's defined the service path index and the service index. Those two values are used to figure out which service function the overlay packet here or the customer packet has to be inspected by. So if you have a service function chain with multiple service function, this service function chain will be identified, as I mentioned again, with the service path index, and service index will tell us which hub or which service function the packet will be inspected by as it traverses the service function chain. That calls for having that service topology, which is consisting of those service function, programmed to the data path such that that functionality will be achieved. So in here, in the Geneva applicability, we are talking about two options or two control plane options to set up the data path. So the first option is simply using what service function chain architecture we call for. The two options I would say are both compliant to the service function chain architecture. So there is no divergence here to the service function chain architecture. So it can be done with either way to achieve the service topology. So the first option is to go over the service function chain path, all the nodes along the service function chain, and program the SPI and the SI to map to the service function. So that means that if I have multiple service function forwarder connected to the service function, I have to go to every service function forwarder and program the SPI and the SI and program the mapping of the SPI and SI to the service function. So it can be resolved to the service functions and being forward to the service function as a packet traverse. The other option, which is mentioned in the draft, is to have the service topology information programmed only at the ingress point, where you have the policy, for example. So typically with a service function chain, the reason you are doing it, you have a policy that identify certain type of traffic and then direct that type of traffic to the service function chain. So we are saying, how can we program the service topology? How can we program that policy along with the service function chain information at the ingress point? So to do that, we need at the ingress point to identify the whole service function chain, meaning have the list of service function IPs that we need to go through as that overlay packet traverse the service function chain. So this is the other option. So we have two options. One option is to go over every single hub, every single service function forwarder, program the mapping of that SPI, identifying service function chain, service path index is called, and the SI to the service function, or have a list of the service functions that we have to, that the packet, the customer packet, overlay packet has to traverse at the ingress, right? So those are the two options mentioned here. And we are carrying NSH, so the in-cap is going to be carried as defined by the SFC group. The NSH, and this is where we have the alignment I was mentioning about, is that the NSH today has the SPI and the SI. It has as well the metadata, different options for the metadata. So all that is going to be carried. And the good thing is that Geneva allows that to happen, because in Geneva we have the next protocol, and NSH has already have defined for itself an Ether type. So the next protocol on the Geneva would be the NSH Ether type. And the NSH protocol, which is in the NSH header, will be the inner packet protocol, which could be Ethernet, an Ethernet packet as Geneva carry Ethernet packet today. So next slide, please. So this is mechanics. We are talking about defining a new option TLV for the control plane option, the second control plane options that we talked about on the previous slide, on which we are putting the list of service functions that that the packet has to traverse. Okay, so this is only explaining the mechanics. Then going to the next slide. So this, the encapsulation again. It's talking about how the Geneva header is going to have the next protocol and the NSH in-cap, which has a base header, service path header, and the context headers. So this is how the in-cap will look like. So next slide, please. So this is, taking it in action now. So how are we going to do it? And this is taking it in action with what we described at the beginning as the control plane option 2, in which we have that SFL, or service function list, which is simply an option TLV with the IP addresses of the service function. So of course, with that option, we are only programming the SFL at the ingress point, where we are installing the policy for the entry to the service function chain. So if we show here in the topology, we have 3 NVE. Each NVE, from SFC perspective, each NVE is is identified as a service function forwarder, right? But of course, in NVO3, those are NVEs, or network virtualization elements. So each NVE here, we have 3 NVEs, so we are talking about service function chain with 3 service function, okay? Between the NVE, we are going to be using Genève tunnels. So the idea here is that the policy will come to the ingress NVE, which can act as a classifier as well as described in the service, in the SFC architecture. And the policy will say, okay, hey, the packet identified by that classification should go by a service function chain that consists of the 3 service function 1 and 2 and 3. So what's happening is that at ingress NVE, it applies a policy and resolve to the first NVE that's hosting the service function 1. So in network virtualization, a network virtualization control plane typically resolve an overlay IP to, of course, to an overlay instance and to a tunnel endpoint that's hosting that overlay IP. Service function here, if you think about it as a virtual network function, for example, it has its own IP, and we are relying on the network virtualization control plane to resolve that service function IP to the tunnel endpoint within that overlay instance. So the ingress NVE will tunnel the packet, send it to the first NVE along with the SFL list. And will set, of course, what will be set on the packet is the SPI as identified by the service topology control plane, and the SI, which is the starting service functions that we have to point to. Add the NVE1, hosting the service function via which you can reach the service function 1 within a given overlay instance, which is a VNI, for example, in the network virtualization world here with Genève. What's going to happen is that he is going to remove the Genève header, and he's going to cache or create a stateful state mapping the SPI with the current SI on the packet from the NSH header to the SFL or the service function list. So it can be thought of as if this is a firewall state or a stateful caching of a mapping between an SPI, like a contract between the SPI and the SFL or the service function list. Then he is like regular network virtualization work. It's going to remove the network virtualization header or the Genève header and sends the packet with the NSH header to the service function. Packet will come back with the NSH, specifically if the service function is NSH aware. There are other options if it's not NSH aware, but there is no point going over that now. So sends the packet to the service function. When the packet comes back, it will come back with the NSH having the SPI and having the SI, so it can find through those through the SPI via whatever it cached in its own cache, the SFL, so it can regenerate the Genève tunnel header, and as well can find the next service function it has to go through now, the packet, resolves that via the network virtualization overlay, sends that to the next NVE, who is going to be repeating the same thing until we reach the egress NVE, and in there, of course, the whole header as per network virtualization is going to be removed, and we know this is the last hub, and now we can deliver the packet to the customer. So the benefit of doing that is eliminating the need to program the service topology mapping of SPI SI to service function on all on all the network virtualization domain, and we are limiting it only at the ingress where we are doing the classification or have the policy. So this is the main benefit of that approach. As I mentioned, the two control plane approach could exist, is programming the service topology forwarding tables on all hubs, or only limiting it to the ingress point. So Going to the next slide. Yeah, actually, definitely Jim gave us really valuable comments, and we did align the draft to the SFC architecture. So I think, yeah, so that draft is describing how Genève applied to SFC, how it can carry the NSH in CAP, and propose, I would say, an optimization for maybe the more obvious way of setting up the service topology forwarding table across a network virtualization domain with that SFL option that you said, okay, here only at the ingress, we need to program service topology information, but not the whole domain. Yeah, with that, I'm done. So any question?
Yes, Greg Mirsky. So, yeah, kind of very interesting machinery, and I have a question. So you said that when you receive Genève packet with the NSH payload and this SL list, SFL list, so you create certain state.
Correct.
And
so maybe we can go back to this.
Is this state only persists until you receive this NSH packet back, or it persists for longer?
Yeah, we have. That's a good question. That's a good question. It can persist, you know, depending on your implementation, right? So here we are talking about an implementation that you can choose to optimize. So yeah, for the implementation, you could have it persist for a while, right? You know, it's as if you know, if you have implemented firewall before, right? So you create some flow state, and you keep the flow state. If you are monitoring, for example, a UDP session, you leave it until it times out, right? So you can, there are options for the implementation, if this is your question, but I don't think we are going to be defining option, because it's up to the implementer to do his stuff. Right?
I think it will be helpful just to explain possible ramifications of aging and having a stale entries. No, I'm just okay.
Yeah, sure.
Okay.
Yeah, that's a good point.
Yeah.
Yes.
Another question is, so what happens if behind this NVE you have sub SFP? Okay, you have subchain.
Subchain.
Yeah, basically it's not one SFF, but it is several SFFs that located behind this NVE with their SFs attached, and somewhere there you have a reclassifier.
You mean okay? You meant multiple service function to the same.
Yes.
SFF. I think it's described in the document. I didn't.
But you have reclassifier. You reclassify your packet and you change the SPI.
Okay.
So basically, what happens, because then you return back and you don't have a cache for that.
Then if there will be a need to reclassify and have another SPI, then that node is a classifier, and then it will have that extra information, meaning a new SPI and new SFL.
Okay,
and
so basically we end up possible worst case scenario, and we have reclassification in each and every NVE. We need to provision them from the control plane, right?
Actually, okay, I'm not. So two things we have to differentiate here. This is not redefining SFC.
No, I understand, but my understanding of use of this SFL, is that we only program the classifier, and everything else is populated dynamically through SFL.
Sorry, I didn't get what you mean. Can you go maybe?
So you use control plane to program the ingress NVE, which
as a classifier, yes.
Which co-located with the classifier.
Okay.
But if we have, and that's SFC architecture permits to have a classifiers or reclassifiers down the SFP.
Okay.
Okay. So in most outrageous scenario, we have reclassifiers in each and every NVE.
Okay.
So that means that each of them needs to be programmed through the control plane.
Yeah, you are right.
Okay, so basically this is the worst case scenario.
Correct.
If that's the worst case scenario, then why not to use a control plane to begin with all the time? That's
What
the
do you
question.
mean by control plane all the time? Sorry.
The program, the state and mapping between SPI.
We are talking about two options. We are not saying you have to do
Okay.
that option or that option. Right?
Okay, can we take this discussion to this? Because
Yeah,
we're
okay,
technically out of time. I'd just like Frank to have an opportunity to talk.
Yeah, Frank Rockness. Very simple question. So you have another option class defined, and you have within that option class the ability to go into sub-TLVs.
Mhm.
One of your sub-TLVs is HMAC, and that sub-TLV, I think if I look at it the right way, it's already consuming something like 40 bytes, right?
Mhm.
So is 128
Yeah.
enough of a length for you, or do we have another use case where kind of punting things
yeah,
to the
yeah.
future?
That
128 again might be a little bit too restrictive. So question for you.
Sure. Yeah, that's a good point too. I think you are right. Yeah, but I was entertaining the discussions on what 28 bytes that just happened. So
it's already two, right?
yeah.
In one meeting. Not bad.
Okay. Sure. We are going to be presenting the draft as well in SFC tomorrow, right? So I'll be presenting actually tomorrow in SFC. Okay. Thank you very much.
Thank you. So just sorry, one last question. Where do you? This has obviously been around for about a year now.
Connect last November, yeah.
So you haven't asked for adoption yet, I think.
Yeah. We didn't ask yet, but we present it in SFC tomorrow, and then we can send the list.
Okay.
So where do you want to have it adopted here, right? NVO3.
Sorry, Sam.
You want it to adopt in NVO3, correct?
Correct. Yes. It applies more to NVO3. Okay. Thank you very much.
Okay. Can we just have a raise your hands if you've read this draft? Yes. Six or so people. 7 people. Okay. Thank you very much. I think that closes the meeting.
Yeah. If you haven't signed the blue sheets, could you please make sure? I don't know where they are.
Yeah. And if you're the last person to sign, can you bring them to the front, please?
Sorry? We kind of resolved the header options during meeting. It's already before it got adopted.